Hi everyone, and welcome to our next video lesson on 14.3. We're on day 1 of 14.3. We're talking about standard scores for one-tailed data. Now, all of these distributions that we're talking about are normal distributions. They're symmetrical about the mean. So here's the mean, and that's 0 standard deviations. And here is 1 standard deviation, 2 standard deviations, 3 standard deviations from the mean. We've done all that. Now, the benefit of standard scores is now what happens if we have maybe 1.5 standard deviations away from the mean? What percent fall below 1.5 standard deviations from the mean? Up to this point, we haven't been able to calculate that, but standard scores now help us calculate any score that's on this normal curve. So taking a look here, a standard score is observations expressed in standard deviations above or below the mean. So here's how we calculate a standard score. It's another word for a standard deviation. We also call it a Z-score. So if I say Z-score, it's the same thing as a standard score. It's the same thing as a standard deviation. Okay, we take our data entry, our observation, we subtract the mean, and divide it by the standard deviation. So you'll see me write this many times today. The Z-score is equal to the observation minus the mean divided by the standard deviation. Okay, that's how you find a Z-score for any data distribution. That's normal. A percentile describes the percent of observations that lie below the given percent. So if you're in the 85th percentile for height or something like that, 85th percentile is something like right here, and it just you're taller than 85% of other people. So it's always below. It's always the percent that lies below to the left of. Okay? So just that you're aware, that's what a percentile means. So we're talking about one-tailed data today. It's always going to be to the left of a certain Z-score like this one is, or it's going to be to the right of a certain Z-score. It's not going to be both left and right, or it's not going to be in the middle of two Z-scores. It's always going to be either on the less than or the greater than side. So we're going to use our table A here, and you're going to need to have this out, so make sure you take out your table A that I gave you. Table A is a table of areas under the standard normal curve. The table entry for each value Z is the area under the curve to the left of Z. So what this does, class, is it gives us a percentile. If I have a standard score of 0.81, so I'm not 1 standard deviation away from the mean, I'm 0.81 away from the mean. What percentile or what percent of observations lie below a standard score of 0.81? Well, 0.8 Z-scores right here and 0.01, so 0.81 is 79%. So like 79.10% of observations lie below a standard score of 0.81. Okay, so we're going to read this table many times today to get used to it. So here's our first one. We're basically asking if there's a Z-score of 1.39, that's roughly right about here, what percent lie less than? So we would shade all of this. Well, we know that it's got to be greater than 50% because to the left of 0 is 50% of the data, and we're going all the way to 1.39. So what percent is less than 1.39? Well, here's 1 right here. Here's 1.3. So 1.39, I really didn't even have to arrow this one, sorry about that. 1.39 is right here. 9177. So 91.77% of the data lies below a Z-score of 1.39. Okay? And again, it should be greater than 50. 91.77 indeed is greater than 50. Take a look at this next one. What percent of Z-scores lie greater than a negative 2.15? So you guys have to turn your table A over to get to the negative side. So here's a negative 2.15 roughly. And I want all the Z-scores that are greater. I want the percent that is greater than a negative 2.15 standard score. So again, it's going to be significantly higher than 50% because from 0 to the end is 50%, and we're going all the way to negative 2. So a negative 2.15, here's a negative 2.1. A negative 2.15 is right there. So 1.58%. Now be very careful, class, because 1.58 is not the answer. This is the percentile, and a percentile is everything below. So we just found that there's 1.58% that lie below a negative 2.15. We want what lies above. We want all of this green region right here. So underneath the normal curve is 100% of the data. So if I want everything to the right of a negative 2.15, I would take 100 and subtract that. So 100 minus 1.58, our answer is 98.42%. That percent of observations lie greater than a negative 2.15. Take a look at the next one. Which z-scores, what percent lie greater than a 0.56 z-score? So here's 0.56, and I want all of this. So now if I'm thinking about this logically, this is going to be less than 50% of the observations. Okay, because from here to here is 50%, so greater than 0.56 is going to be less than 50%. So if I look at 0.56 in my table, 0.56, 0.7123 or 71.23% lie below a 0.56. So what lies above? 100% minus 71.23. And so that would be 28.77%. Okay, and the last one of this kind. How about a z-score that's less than 3.14? Well, 3 standard deviations away from the mean, we found this out in a previous lesson that it's abnormal to be more than 3 standard deviations away from the mean. So 3.14 is just about all of the data. It's going to be really close to 100%. It's going to be all of this, right? So a 3.14, if we take a look at 3.14 is right there. 99.92% of the data lies below 3.14 standard deviations away from the mean. Almost 100% of the data, really close. So how can we use this? Here's a situation. Jenny, she took the SAT, she got a 600. Gerald, he took the ACT and he got a 21. Well, who did better between the two? It's kind of tough to compare two data distributions. Now we can, because they're both going to be normal, and we could then compare their z-scores. Whoever had the higher z-score did better on that test. So let's first find the z-score for Jenny. So the way you find the z-score, I'll write it many times today, the z-score equals the observation minus the mean divided by the standard deviation. So the observation that Jenny got, her score was a 600. We subtract the mean, we subtract 500, because the mean of the SAT is a 500, divided by the standard deviation of the SAT, which is 100. So 600 minus 500 is 100, and 100 divided by 100, her z-score for Jenny is a z-score of 1. So Jenny is right here. So she did better than average. This is where Jenny is. How about Gerald? Here's the z-score for Gerald. His score was a 21, minus the mean of the ACT is an 18, divided by the standard deviation is 6. So 21 minus 18 is 3, and 3/6, the z-score for Gerald is 3/6, which is 1/2. So here is Gerald's z-score at about a half. So who did better on the test? Jenny is the one that did better because she had a higher z-score. We could find their percentiles by looking at the table A to see what percent they are both at and stuff like that. But Jenny's z-score is higher, so Jenny did better on the test. Let's take a look at this one. What percent of people score above a 750 on the SAT? Well, if we want to find a percent, we first have to find their z-score. So to find their z-score, we take the observation, 750, subtract the mean. The mean of the SAT is a 500, and divided by the standard deviation, which is 100. 750 minus 500 is 250. 250 divided by 100, the z-score is a 2.5. So we want to know what percent of people score above a 750 or above a 2.5. So a 2.5 is right here, and I want to know what percent score better than that. Not very many score higher than a 750 on the SAT. Very, very small percent. So if we take a look at the percentile, our table A, 2.50 is right here. 99.38%. And again, class, a percentile is observations that lie below a given z-score. So 99.38 is all of this red. We don't want that. We just want this little bit of green. So it's 100% minus 99.38. That's the percent of people that score higher than a 750 or higher than a 2.5. So if you subtract the two, you get 0.62%. Not very many people at all. What percent of people score below a 25 on the ACT? Well, to find a percent, we got to find the z-score. So the z-score of a 25 is 25 minus the mean divided by the standard deviation. 25 minus 18 is 7, and 7 divided by 6, the z-score rounds out to 2 decimal places, is 1.17. So 1.17 is about right here. And we want the percent that fall below a 25. So that fall this way. It's going to be greater than 50% because it's higher than 0, and 0 is 50% of the data. So 1.17 is 87.90. 87.90% of the data fall less than 1.17 standard deviations from the mean. Here's question number 8. What percent of people score a 30 or higher on the ACT? Once again, if it's asking for a percent, I'm going to say, what is the z-score? Because I could always match a z-score to a percentile in our table A. So what is the z-score of a 30 minus the mean minus an 18 divided by the standard deviation of 6? 30 minus 18 is 12, and 12/6 is a z-score of 2. So here's our z-score of 2, and we want to know what percent of people score higher, so better than that. Not too many score higher than a 30. It's abnormal to score a 30 or higher. There's a few percent. What few percent is that? Let's go to 2.0. Here's 2.00 is 97.72%. And that's the percent that of people that are a z-score of 2 or below. Remember, a percentile is everything that lies below a given z-score. So what lies above? What is this? 100 minus 97.72. So the answer to that is then 2.28. 2.28% score better than a 30. Okay, now we're just going to switch around a variable. This time, you know what the standard score is. I'm telling you that a person got a standard score of 1.4. Well, what was their actual score on the SAT? So in our formula, the z-score equals the observation minus the mean divided by the standard deviation. I will always give you the mean. I will always give you the standard deviation. Sometimes I give you the score, and you have to find the z-score. Other times, I'm going to give you the z-score, and you have to find their actual score. So 1.4 is the z-score. That's the standard score. What score did they get? That's x minus the mean, so minus 500, divided by the standard deviation of 100. So we'll cross multiply both sides by 100, and I'm going to solve for x. So then we get 140. That equals x minus 500. Simply add 500 to both sides. And what score did that person get on the SAT? They got a 640. They got a 640. Why don't you guys pause the video and try this last one on your own, please. Here's what you should have got. Once again, the Z-score we know is a negative 0.5. So they did less than average on the ACT. They did left of the mean. So just by that, we should know they got less than an 18 because an 18 is the average. So if it's a Z-score of a negative 0.5, that means they did less than average. So less than 18. So 0.5, that equals the x, what we want to find, minus the mean, 18, divided by the standard deviation of 6. Multiply both sides by 6 to get a negative 3. That equals x minus 18. Add 18 to both sides, and x equals 15. A person who is a negative 0.5 standard deviations left of the mean got a 15 on the ACT. Hopefully that made sense to you. If you have any trouble reading Table A, be sure to come to me tomorrow. I'll try to make more sense of that. Otherwise, let me know if you have any other questions when you get to class tomorrow as well.